In this video, I review the key terminology and structure that you must understand before you begin using 3DEXPERIENCE for engineering design. As an engineer, I like contextual examples. So, let's assume that I am going to develop and sell this simple load transfer device. First, I will discuss how to design the load transfer device, using traditional engineering tools. Then, I will briefly explain the 3DEXPERIENCE platform. This will help you understand the value the platform provides, and why it is a bit more complicated than the traditional standalone engineering tools. Finally, I will explain the key terminology and structure that you need to know to start designing with 3DEXPERIENCE. I need 4 parts to make my load transfer device: a frame, a bracket, and a bolt and nut. Working with a traditional set of engineering tools, I would use a CAD software, like SolidWorks, to create 3D models and drawings of the parts and assembly. I might use a CAE tool, like Abacus, to perform a structural analysis. And a tool like GibbsCAM, to define how I will manufacture the parts. I use a defined engineering methodology, described in Word or PDF documents, and I perform calculations that validate my design using tools like Excel. I may even provide some assembly instructions. I store all the files associated with my load transfer device in a Windows folder. Even if I am using a PLM system, there are still files. The PLM system just improves the file management processes. But, even with a PLM system, mistakes can easily occur. For example, the PLM system can't guarantee that the material properties used in my structural analysis are consistent with those defined in the CAD model. Speaking broadly, 3DEXPERIENCE is an enterprise-level, business platform. But for our context, we can consider it to be a digital engineering platform. It provides CAD functionality that is similar to SolidWorks, and simulation capabilities similar to Abacus CAE. And the Delmia apps provide comprehensive manufacturing-related functionalities. The 3DEXPERIENCE platform also provides collaboration and management tools that engineers need to develop products. More importantly, it significantly improves data management and design efficiency by ensuring that everyone works with a single source of data. So, one should expect that using 3DEXPERIENCE will be a bit more complex than a standalone CAD system. Now that you understand the 3DEXPERIENCE platform, in the context of engineering design, I can use the load transfer device to explain the key terminology and structure. To facilitate the discussion, I define the load transfer device in SolidWorks and 3DEXPERIENCE. In SolidWorks, I created the 4 parts and arranged them in an assembly using assembly mates. The process in 3DEXPERIENCE is similar. But, the object names and their functionality are a bit different. In SolidWorks, a part is a 3D representation of a physical part. In 3DEXPERIENCE, the 3D shape serves a similar purpose. Note the icon associated with a 3D shape. Learning the icons will help you quickly differentiate between objects in the tree. The 3D shape contains a default set of datum planes, and it has an object called the part body. The part body contains all of the part's geometric features and may also contain any construction geometry. The names of the geometric features may be a little different than you are accustomed to. But the icons look very similar. So, you will quickly learn how to use the 3DEXPERIENCE features. Sketches work pretty much the same way. Most extruded or revolved features are created from a sketch. And within the 3D shape, you can use geometric sets to store surface and wireframe geometry. At this point, I need to briefly discuss geometric sets and ordered geometric sets. The native 3DEXPERIENCE apps, like Part Design, allow one to create both geometric sets and ordered geometric sets. You can use this YouTube link to learn the differences between the two. Please also note that the web-based CAD app called XDesign always creates ordered geometric sets. However, when using the native apps like Part Design, ordered geometric sets should be used only in very select circumstances. Therefore, we recommend that you create geometric sets. Now, we can begin discussing the higher levels of the tree. Just above the 3D shape there is an object called a 3D part. The 3D part contains all the information needed to generate a physical part. Again, notice the icon. Every 3D part contains one, and only one 3D shape. But, we also require many other objects to produce a physical part. 3DEXPERIENCE creates associative links between these other objects and the 3D part. Some of these objects can be created by right-clicking on a 3D part and selecting Insert. The objects associated with a 3D part may include multiple markups or drawings, or representations used to perform physics simulation. It may also include an engineering specification. Please note, this is not used to attach your specification documents to the part. Rather, it creates a knowledge engineering specification for the part. Knowledge engineering is a powerful tool to create parametric decision rules in your models. Before moving on to explaining the assembly, I need to quickly discuss the creation of new 3D parts. The dialog box for creating new 3D parts can confuse new users. The source of this confusion is the default title. When looking at this title, I may mistakenly think that I am creating a physical product. However, as the window labels indicate, we are indeed creating a 3D part. In SOLIDWORKS, the assembly is a 3D representation of our load transfer device. It is a collection of the parts associated with the load transfer device. To model an assembly, 3DEXPERIENCE utilizes an object called a physical product. The physical product contains all the information required to create the load transfer device. The icon for a physical product looks like two assembled blocks. The physical product includes the 3D parts associated with our device, and engineering connections that define how the parts are arranged in space. Engineering connections are similar to the assembly mates in SOLIDWORKS. To produce the physical assembly of something like our load transfer device, we require many other objects. 3DEXPERIENCE creates an associative link between these other objects and the physical product. Similar to the 3D part, you can include many of these objects by right-clicking on the physical product. For physical products, you need to select Insert and Representation. The inserted objects may include 2D drawings of our product. It may include a mechanism model. Such models help us evaluate how our product will operate, and it may include a kinematic analysis or even a mechanism with an integrated control system. It can include an unlimited number of 3D shapes or simplified shapes used to determine how to package the components of a very large assembly. It may include a copy of the design geometry that is simplified for performing physics simulations like CFD or FEA. Or even the grid or mesh that is used to perform the physics simulation. So far I have discussed the objects that can be associated with a 3D part or physical product by right-clicking on the tree and selecting Insert. However, we have several other objects that we want to associate with our 3D parts and physical product. These include assembly instructions, the engineering specifications describing our design methodology, the engineering calculations required to validate our design, and material data. We use the Engineering Release app to associate engineering documents with 3D parts and physical products. This app allows us to view all the items associated with the load transfer device. To add a supporting document, we simply highlight the 3D part or physical product that we want to associate our document with and click on the plus sign. Then we simply navigate to the document. So let's review the objects associated with the load transfer device using a simple diagram. At the top level we have a physical product with the title bolted joint assembly. This physical product contains 4 3D parts. Each 3D part has exactly one 3D shape. Each 3D shape contains datum planes and the geometric features that define the part. The engineering connections created at the physical product level define how the parts are arranged in space. Remember, they are similar to the assembly mates in SOLIDWORKS. The collection of 3D shapes and engineering connections defines the assembly mockup. Each 3D part has a material associated with it. In addition to materials, we also have objects used to perform structural simulation. Each 3D part has a geometric abstraction of the 3D shape geometry and a finite element mesh. At the physical product level, there is also a finite element model used to evaluate the performance of the complete assembly. We have engineering drawings for the frame, the bracket, and the entire assembly. We also have an engineering document associated with the bolt 3D part. And a mechanism analysis associated with the physical product. Finally, there are several additional engineering documents associated with the physical product. Our diagram captures the bill of materials for our load transfer device. We can use the Engineering Release app to view the bill of materials in 3DEXPERIENCE. At this point, I want to provide some additional important details about physical products. Physical products can include an unlimited number of physical products and 3D parts. In this example, I have placed our bolted joint assembly into another physical product titled truck frame. The physical product for a complex device may include hundreds of physical products and thousands of 3D parts. I also want to highlight that we could have used physical products for all of the components in the bolted joint product. Looking at it diagrammatically, I have physical products where the 3D parts used to be. Each physical product has a 3D shape. The rest of the structure looks the same as it did when I used 3D parts for each component. Notice that in this case, we assigned the materials at the product level. When we used 3D parts for the 4 components, we assigned a material to each 3D part. Materials may be assigned to a 3D shape, 3D part, physical product, or even to a specific region of a finite element model. If your product structure includes 3D parts, the material should be assigned to the 3D part. You should now have a sufficient understanding to start using 3DEXPERIENCE to design your own devices. However, since you may also have access to the Delmia manufacturing apps, I want to briefly describe how the manufacturing and design data is connected. If I launch one of the Delmia manufacturing apps, like milling and machining, it creates an object called a PPR context. PPR stands for Process, Product, and Resource. Process objects include things like operations programming to create NC codes. The products include the design data for our load transfer device. It may also include raw materials or jigs and fixtures needed to make the device. The resources include the machines and tooling used to manufacture the parts.